evening. Today we are going to look at probability theory. First of all, the word probability in a layman's language means chance. Chance. So mathematically we can define probability as the measure of chance of an event occurring or not occurring. Whether an event is occurring or not occurring. So the measure of a chance of an event occurring or not occurring is what is referred to as probability. Under probability, we have some terms which we have to look at. We have what we call an event. We have an event, then we have what we call outcomes, and then we have what we call sample space. Sample space. So sample space is the set of all possible outcomes of any experiment. The set of all possible outcomes of any event is what is referred to as what? A sample space. For example, when we roll a die, or when a die is rolled once, you find that the sample space will be equal to the numbers which appear on the faces of the die. The die consists of 6 faces labeled from 1 up to 6. That is 1, 2, 3, 4, 5, and 6. So those figures there from 1 up to 6 form the sample space on the die. So if you are asked to state the number of the sample space of the die, we can abbreviate it as number of S is equal to 6. Why? Because we have 6 faces on the die. Similarly, when we toss a coin, there are 2 chances which can occur. Either a head can show on top, or if the head has not shown on top, then it is the tail. So meaning that the sample space for tossing a coin once is 2. Why? Because we have 2 faces on the coin, labeled H and then T. Usually when we are determining a game, or when it is to start, what happens is that for one to know the side which is to start first, we use the knowledge of probability, whereby we get a coin and then we toss it. So if a head occurs on top, then it means the side that it chose a head will be the one to start, and the reverse is true. That is to say, if the tail shows on top, the team that it chose the tail will be the one to start first. So normally we can use it in determining which side is to start first. Then we look at, under probability, we also look at what we call events. Events. An event is a subset of a sample space. That is to say, part of a subset, part of a sample space is what is referred to as what? An event. In other words, some of the outcomes on the sample space form what we call an event, or events of the what? Of the sample space. Like when we toss a coin, twice, you find that there are a number of events which occur. There are a number of events which occur. So we can look at an example of tossing a coin twice. Twice means 2 times. Twice means 2 times. That when you toss a coin 2 times, what are the chances which can occur? Or which events occur? The events which occur are, there is a chance whereby we can get a head and then a head also. Because here is a situation where we are tossing a coin and then we also toss a what? A coin 2 times. So there is a chance where we can get a head and a head also. That is to say, a head on one coin and a head on another coin. There is a chance where we can get a head and a tail. So there is a chance where we can get a head and then we can get a head and a tail. We can get a tail and then a head. Then we can get a tail and another tail. So we can say that there are 4 chances when we toss a coin 2 times. There are 4 chances which can occur. So all of these are called events. We call them what? Events. And therefore, if we are asked to find the number of sample space for tossing a coin twice, will be, we say number of S is equal to, you count all the events which are there. 1, 2, 3, 4. So which is equal to 4. It means the sample space, the total sample space is equal to what? 4. When you toss the coin once, the events which can occur, or the outcomes which can occur, we can get a head or we can get a tail. That is when you toss the coin once, meaning that the sample space will be what, by counting the number of events which are there, either a head or a tail. So meaning that number of the sample space will equal to, there are 2 of them, 1, 2. So it is 2. That is the number of what? Of sample space. So generally, the probability of an event, which we can abbreviate as P of E, is got by the formula number of events, that is number of E, divided by number of sample space, number of S. So probability of an event is equal to number of E events over the number of sample space. So if there are 2 events, you will divide 2 by the sample space. If there are 6, you divide by the sample space, which is 6. So that is the formula for finding the probability of an event. So we can now look at an example. A worked example. The question says, find the probability of getting 2 heads when an ordinary coin is tossed twice. When we toss a coin twice, find the probability of getting 2 heads. Now here we need first of all to form what we call sample space. Tossing it twice means that we are going to have a sample space of 8. How? We can list all the events which are going to occur. The events here are, we can have head, a head, and then a head. That is one chance. Or if that one has not occurred, we can have a situation of getting a head, and a tail. Or if that one has not occurred, we can have a head, a tail, and a head. If that one has not occurred, then it can be a head, a tail, and a tail. If not that, it can be a tail, tail, tail. If not, it can be a tail, tail, head. If not that, it can be a tail, a head, and a tail. If not, it can be a tail, tail, head, that one is already there. Tail, head, tail, head, head. Tail, head, head. So we can say that when we count 1, 2, 3, 4, 5, 6, 7, 8, we have exhausted all the chances which can occur when a coin is tossed 3 times. So meaning that in this case, number of sample space is equal to 8. Number of sample space will be equal to what? 8. So after getting the number of sample space being equal to 8, remember the question was saying, find the probability of getting, find the probability of getting, find the probability of getting 2 heads when an ordinary coin is tossed. Getting 2 heads. Now 2 heads, we shall list the events where we have 2 heads. The 2 heads are, we have 2 heads here. We have 2 heads here. We have 2 heads here also. Tail and head. So we can say that the events are, the events for 2 heads are, we have head, tail, we have head, tail, head, and then the other one is tail, head. Meaning that the number of events is equal to 3. We count them 1, 2, 3. The number of events is equal to 3. So number of events is equal to 3. So therefore, probability of getting the 2 heads will be got by number of events divided by the number of sample space, whereby the number of events here is equal to what? 3. Number of sample space is equal to 8. Therefore, 3 over 8 will be the probability of getting the 2 heads. So that is how you work out such a question. If you were asked to find the probability of getting 3 heads, you find that there is only 1 chance. Head, which is 1 out of 8. If you are asked to find the probability of getting 0 head or not getting a head, you find that there is only one chance, where we have T, 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 tail, tail, tail. So probability will be 1/8 also. So that is how we tackle such a question. We can look at another example. The question says, find the probability of getting a number greater than 3 when an ordinary die is tossed. Find the probability of getting a number greater than 3 when an ordinary die is tossed. So here we need to know, first of all, the sample space of the die. For the die has 60 faces. So meaning that sample space of the die is equal to 1, 2, 3, 4, 5, 6, because there are 60 faces on the die. Now, they want us to find the probability of getting a number greater than 3. So among these, there are some numbers which are greater than 3. The numbers greater than 3 are 4, 5, and 6. So probability of getting a number greater than 3 will equal to the number of events, which are 3 of them, divided by sample space, which is equal to 6. So first of all, the number of sample space is equal to 6. So number of events greater than 3 are 3 of them. So the events number of we can say numbers greater than 3 are, we have 4, we have 5, and then 6. Those are the figures. Meaning that the number of events is equal to what? 3. We count them 1, 2, 3. So probability it means that number of events is equal to what? 3. So probability of getting a number greater than 3 will equal to the number of events over the number of sample space, whereby the number of events, there are 3 of them, over the number of sample space, which is 6. But when you look at the 3 and the 6, they have a common factor. So we shall reduce by 3 once, by 3, 2. So we shall have a half. So therefore, the probability of getting a number greater than 3 is equal to a half. We can continue. So we can look at the principle of exhaustion. In a particular context, with a set of exclusive outcomes, e.g., A, B, C, the sum of probabilities is always equal to 1. Meaning that when you add all probabilities, we must always get what? 1. We don't have any probability that is greater than 1. The highest probability that we can get is 1, and the lowest is equal to 0. So the probability of a certain event is equal to 1, and the probability of any impossible event is equal to 0. When we talk of a certain event is the event that you are sure of. When you are sure that something is going to occur, then its probability is equal to 1. But when you are not sure, or when something is impossible, when an event is impossible, that is to say, when it cannot happen, then its probability is equal to 0. For example, you may be asked that given that today is Monday, what is the probability that tomorrow it will be Thursday? Automatically, the answer is 0. Why? Because if today is Monday, tomorrow it cannot be Thursday. So that is an impossible event. But if you are asked that if today is Tuesday, what is the probability that tomorrow it will be Wednesday? The answer is 1. Why? Because if today is Tuesday, whether I like it or not, tomorrow must be Wednesday. So that is certain event. You are very sure that it will happen. So when you add probabilities of exclusive outcomes, the answer must be equal to 1. That is to say, for given probabilities for given events A, B, and C, probability of A plus probability of B plus probability of C must be equal to 1. Whether there are 100 of them, you will add all of them, but the answer is 1. P of A plus P of B plus P of C plus P of D, depending on the number you will be given, you must always get 1. Using this formula, we can look at an example. Before we look at this example, there are some key terms which we need to understand in probability theory. There is this word, the O. O in probability theory means union, and union means addition. Then and, the word and means multiplication. If they say probability of A and B, you have to multiply probability of A times probability of B. If they say probability of A or B, it means you have to add the probability of A to probability of B. So those are very, very important notes which must be understood. So we can look at an example. The example says, a ticket is randomly selected from a basket containing 3 green, 4 yellow, and 5 blue tickets. Determine the probability of getting A green ticket, B, a green or yellow ticket, C, an orange ticket, D, a green, yellow, or blue ticket. So we can answer this. They are saying a ticket is randomly selected from a basket containing some tickets. Assuming that this is our basket, okay, if this is our basket, assuming that is our basket, this basket consists of some tickets. There are some which are green. They say the green ones are 3 green, 4 yellow. We have 4 yellow tickets. and the 5 blue ones. 5 blue tickets. Look at that. So they are saying a ticket is randomly selected. If they say only one ticket is picked or randomly selected, it means that we shall have only one set of branches. One set of branches. So in this case, these branches will be divided in this form. We have green, we have yellow, and then we have blue. Sample space for all these tickets will be obtained by adding all the number of tickets which are there. So in this case, we have 3 plus 4 plus 5. 3 plus 4 is 7, and 7 plus 5, we get 12. It means the sample space is equal to 12. Now, probability of picking a green ticket will equal to the number of green tickets divided by sample space. So probability of picking a green ticket will equal to 3 number of green tickets divided by sample space, which is 12. Probability of picking a yellow ticket will equal to the number of yellow tickets, which is 4, divided by sample space, which is 12. And the probability of picking blue tickets is equal to the number of blue tickets, which is 5, divided by the sample space, which is 12. So we write the probabilities like that. So to prove that these probabilities are true, when we add all of them in the 3 branches, we must get 1. That is 3 over 12 plus 4 over 12 plus 5 over 12. The answer must be 1, which is true. So, having drawn that, this diagram is called a tree diagram. Having drawn that, we can now use it to answer the question. The question says, determine the probability of getting a green ticket. A green ticket. So we say probability of getting a green ticket. Green ticket is equal to, the answer is already there, which is 3 over 12. But we cannot leave it 3 over 12 as it is, since 3 and 12 have a common factor. When we reduce by 3 once, by 3, 4, so the answer will be a quarter. So the probability of getting a green ticket will be a quarter. This is part A. Part B, they want us to find it's okay. Part B, they want us to find the probability of getting a green or yellow ticket. Probability of getting a green or yellow ticket is equal to From the beginning, I said that the word "or" carries a meaning in probability theory. "Or" means union, and union means addition. So probability of green or yellow is equal to P of green or yellow is the same as the probability of green plus probability of yellow. But the probability of green is 3 over 12. 3 over 12, which is the same as a quarter, plus probability of getting yellow is 4 over 12. 4 over 12. Getting the LCM, which is 12. 12 divided by 4 is 3, and 3 times 1 is 3. 12 divided by 12, you get 1, and 1 times 4 is 4. So that here we get 3 plus 4, we get 7 over 12. So probability of getting green or yellow card is 7/12. We cannot reduce there. But see, they want us to find the probability of getting an orange ticket. Probability of getting an orange ticket. P of orange. Of getting an orange ticket is equal to, we don't know. Remember, we said that when an event is impossible, its probability is equal to 0. When you look at our probabilities, our events, there is no chance where we can get an orange ticket, because in our basket we don't have any orange ticket. So probability of getting an orange ticket, P of an orange ticket, is equal to the number of orange tickets, over the number of sample space. So in this case, probability of getting an orange ticket is equal to the number of orange tickets is 0. We don't know, they are not there. Over sample space is 12. So 0 divided by 12, we get 0. So this is a situation where we can get 0 probability, something that is impossible, because we don't have an orange ticket in the basket. They want us to find the probability of getting a green, yellow, or blue ticket. Probability of getting a green, yellow, or blue ticket. So we remember we said that the word "or" means addition. So this is the same as probability of getting green plus probability of getting yellow plus probability of getting blue. But the probability of getting green, we got it as 1/4 plus probability of getting yellow, P of yellow was 4/12, 4/12 plus probability of getting blue is 5/12. 5/12. So we can add all the probabilities. So in this case, the LCM is 12. 12 divided by 4 is 3. 3 times 1 is 3. 12 by 12, we get 1, and 1 times 4, we get 4. 12 divided by 12, we get 1, and 1 times 5, we get 5. This gives us now 3 plus 4, 7 plus 5, we get 12. Out of 12, giving us 1. So the answer is 1, which is the highest probability we can have. So probability of getting the green or yellow or blue is 1. And indeed, all of them are there. So it means the chance of getting all of them, blue, green, or yellow, is 1. That is that. We can now look at what we call complementary events. If E is an event, then E dash is the complementary event of E. The complementary event is the event that does not occur. In other words, when the event has not occurred, we say it is complementary. So, the complementary event is represented by a dash, or we can use a word prime. So, if we have an event E, for event E, then it's a complementary event, or the complement of event E, complementary event for A will equal to E prime. We use that to name the complementary event. A prime, that. So, the probability of an event plus the probability of its complement must always equal to 1. That means that the probability of any outcome occurring plus the probability of any outcome not occurring must always equal to 1. Meaning that the probability of an event not occurring is equal to 1 minus the probability of an event occurring. For example, if the probability that a student will pass an exam is 1/3, then the probability that he will fail the exam will be 2/3. How do you get the 2/3? You will get the probability of passing plus the probability of failing is equal to 1. Such that probability of failing will equal to 1 minus the probability of passing. So these are what we call complementary events. So we are saying probability of any event plus probability of its complement, E dash, must always equal to 1. Or probability of an event occurring plus probability of an event not occurring must always equal to 1. Such that P of E will equal to will equal to 1 minus P of E dash. Or P of E dash is equal to 1 minus P of E. The reverse is true. We can look at an example. The question says, an ordinary 6-sided die is rolled once. Determine the chance of getting a 6. Determine the chance of getting a 6. So here, we need to know first of all, if they say it is a die, the die has got 6 faces, meaning that the sample space of the die will equal to 1, 2, 3, 4, 5, 6. You list the number of faces on the die. Now, if an ordinary die is rolled once, determine the chance of getting a 6. So, probability of getting a 6 will be obtained by the number of 6s which are there over the number of sample space S. In this case, we look at how many 6s do we have there. We can say that there is only 1 6. So the event is 1. So probability of getting a 6 is 1 out of the sample space which is 6. So the answer will be 1 over 6. Part B, they want us to find the probability of getting a 1, of not getting a 6. Probability of not getting a 6. So this now takes us to complementary events. Probability of an event occurring plus the probability of an event not occurring is equal to 1. Meaning that probability of getting a 6 plus the probability of not getting a 6 is equal to 1. So, we shall say P of not getting 6 plus probability of getting a 6 must give us 1. So the question requires us to find the probability of not getting a 6. So probability of not getting a 6 will equal to 1 minus probability of getting a 6. So this gives us 1 minus probability of getting a 6, we got it as 1 over 6. And therefore, when we simplify this, we shall have 6 minus 1 out of 6, which is 5 over 6. So the answer will be 5 over 6. Next is part C. They want us to find the probability of getting a 1 or 2. Probability of getting a 1 or 2. The word "or" means addition. So meaning that we need to get the probability of getting a 1. Then we also get the probability of getting a 2. We add them. So in this case, P of getting a 1 is equal to the number of ones which are there, which is 1, out of the sample space 6. Probability of getting a 2 is equal to the number of 2's which we are seeing on the die. There is only 1 2. That is 1 out of 6 now. So probability of getting a 1 or 2 will now equal to probability of getting a 1 plus probability of getting a 2. But the probability of getting a 1 is 1 over 6, plus the probability of getting a 2 is also 1 over 6, giving us a 2 out of 6, which is a third. So therefore, the answer will be a third. That is the probability of getting a 1 or 2. Then the next is part D, which says find the probability of not getting a 1 or 2. D, probability of not getting 1 or 2. This now takes us to the other formula, that is probability of an event occurring plus the probability of an event not occurring is equal to 1. So probability of not getting 1 or 2 is equal to 1 minus the probability of getting a 1 or 2. So in this case, this will equal to 1 minus the probability of getting 1 or 2. But this gives us now 1 minus probability of getting 1 or 2 is a third. And when we simplify, 1 minus a third will give us 3 minus 1 out of 3, giving us 2 over 3. So the answer will be 2 over 3, which is the same as 0.667 when converted to decimal place. Next, the next is now an exercise. So this is about probabilities. This is how we calculate probability. Next time when we meet, we shall look at tree diagrams, how we can use the tree diagram method to work out probabilities. Our lesson of today is ended there. Thank you for listening.